Hello everyone, welcome to SQL Maestro's session on top 5 developer best practices in SQL Server. Thanks for joining. Let's see what is the content that's planned for today. Zoom in into the demo files, there you go. The first demo is going to be about sargability, followed by implicit conversion, followed by SQL injection, then dynamic SQL plan cache, and the last demo is going to be the usage of select star in SQL Server. So really 5 demos are planned, but let's see how much time we have and if we are able to cover 4 or 5 of them. Now the motivation behind these so-called top 5 developer best practices is that I see these common mistakes that developers make. And when I say developers, I don't only just mean application coders or programmers, but I also see people who work with SQL Server day in, day out, DBAs or architects. They kind of tend to make similar mistakes. And that's how I have these learnings and just compiled them into this session. Before I begin with the first demo, I just want to quickly make all of you aware of the SQL Maestro's membership plans. So if you go to sqlmaestros.com and click on join here, you look at the link join there on the menu item, you can join SQL Maestros as a free member and get access to all our tutorials, all our free webinars, all the free resources, everything that's out there freely available on sqlmaestros.com. But there's a lot of content that's so-called advanced, which includes paid webinars and advanced tutorials and demos that's available as part of premium membership. And you can take up annual membership and get access to all of that. So just be aware of it and you can choose whatever suits your needs. Okay, let's jump back to the VM and start with the first demo, that is non-sargability. Let's double click on this file, non-sargability.sql. So what is meant by sargability? It's not really an English term, so to say. It means search argument able. I mean, it's combined in this fashion. And in other words, it means the optimizers or SQL Server Engine's ability to perform a seek operation while searching based on an argument. And instead of talking too much theoretical and jargon wise, let's straight away jump into the demo and you will understand what is a sargable behavior and what is a non-sargable behavior. But just for the starters, you want sargable behavior, which means you want the optimizer to seek based on the argument that you provide in the predicate. Let's use AdventureWorks 2016 for the purpose of demo. We are creating an index on this table, sales order detail, and the index column that we choose is modified date. Now the include keyword here is not so important. What is more important is the attribute modified date, which means we are going to write a query where we will have modified date in our predicate and we will expect SQL Server to seek upon this index that we create. So let's go ahead and create the index. If it's not already there, yes, it wasn't there and we have created this. I'm not turning on time and statistics, etc., because this is very, very elementary and basic for you to kind of know that in most cases, seek will perform better than scan. And let's not talk about edge cases here right now. So what's the query? This is the query in front of you, a very straightforward query where you are selecting a few attributes from sales order header. You're also joining a table sales order detail. And then comes the important part here, which is this where clause. Now, if you look at this where clause carefully, you are putting up a predicate here on modified date and you say modified date is equal to this particular date. And you know where the problem is. The problem is on the left hand side of the equality operator, you are doing some mathematics with this column, with this attribute, which will make SQL Server lose this sargable behavior. And let's talk about that in a moment. Let's first go and execute this. Before we execute this, let's turn on the actual execution plan. Now, we already have an index on modified date, and what you would have expected that there will be a seek operation on modified date. And the idea here is SQL Server really doing a seek operation or not? Let's go and execute this. We execute, okay, we don't get any output, which is fine, doesn't matter. Let's jump over to the execution plan, and you can see that SQL Server is actually not seeking on this index that we created. We created this index, right? IDX SOD modified, and you can see SQL Server is actually performing a scan operation. Now, what essentially is happening here is when you use T-SQL functions, most of them, on the attribute, and this attribute is on the left hand side of your operator, it loses its attribute related characteristics and preventing the optimizer to perform a seek operation. So after you have applied this T-SQL function on the attribute, what you're essentially doing is you are converting the attribute to each value, and basically now SQL Server is just comparing one value with another, or one literal with another, and thereby the optimizer is not able to perform a seek operation, which means this is now a non-sargable behavior. Ideally, if this would have been written in a different way, and we will come to that in a moment, we would see sargable behavior. But what is happening is you are seeing non-sargable behavior. You know, in many cases, these things go unnoticed because there's no error really. Yeah, right? The query does execute, and at least in my example, it runs very quickly. But imagine a scenario where you're dealing with a table which has like millions of records. You would start facing the heat when you know the difference between seek and scan. Scan is like touching every record, and seek operation here means that you're traversing the B tree structure of the index, only touching upon the data that is required. That's really the beauty of indexes and traversing the B tree structure, which is the seeking capability. But now that seeking capability is gone and you're scanning, which is where it is hurting performance. So what is the fix? The fix is really, in simple words, is keep the left hand side of the operator as clean as possible, which means I'm just rewriting the T-SQL in this way, where I'm trying to say where modified date is greater than equal to something and less than something, whatever. It should be functionally equivalent, right? Logically, functionally, this query is same as the previous one. But now if you look at the where clause, I am not doing any operation. I'm not doing any mathematics on modified date. And hopefully now SQL Server will be able to perform a seek operation. This is what we want. So if I select this and let's go and execute now, jump over to the execution plan, and now you can see that SQL Server has performed a seek operation. So you have the index, and now you can see an index seek. And as I said earlier, and iterating again, if you're dealing with big data here, with large data, if the table is huge, you would really see the difference in terms of execution time, in terms of CPU time as well. You would be able to see that. And you can verify that when you turn on set statistics time on. So this is what is meant by sargable behavior versus non-sargable. You know, when I talk about these things and I demo it with a lot of developers and DBAs or anyone in general working with SQL Server, some people do know it, but I come across so many people who do not know this because, again, iterating again, they would be like, yeah, my index is being used, right? In both the cases, index was being utilized. That's the key aspect. Just because an index is utilized doesn't mean that everything that is happening is right. Index is being utilized, but not the right way. So in the earlier example, it was scanning the index, and now you are seeking upon the index, and this is what you want. Likewise, you could actually take more similar examples, and I have some more examples in the script here. If you just take these two for the starters, right? Look at this one. You're searching across this table email address, and there's an index on email address, and you say like Aaron percentage. This one versus this one where you say like percentage Aaron. So let's run both of them. And now I think you can get a sense of it. This first one is sargable and the second one is non-sargable. Let's first execute this and see it for ourselves before we jump into more discussion. Jump over to the execution plan and what you can see here is the first one. This is the query. These are the plan in front of you. Let's go, oops, not the tooltip. Let's go and zoom in to see a bit. The first one, right? Okay, let me stop somewhere here. I think this will give a full view. Okay, perfect. First one, you can see in the first one here, it is Aaron percentage, which means now the optimizer can seek on this attribute email address. Why? Because it knows the starting point. It knows it has to start seeking from this starting point of Aaron, which is AARON, and you can clearly see that it is seeking, and this is what you want. For the second one, which is non-sargable, when you put a wildcard character here before the actual literal percentage, SQL Server does not know the starting point. So how can it really seek? It's a wildcard character and it doesn't know where to begin from. And this is where it starts scanning and is now touching every row in the index. So this is B-tree navigation. The first one is B-tree navigation, and this one is just touching every row. And you know, from the optimizer's perspective, in terms of cost analysis, you can clearly see what optimizer thinks that, wow, seeking is just 2% of the cost compared to 98% of the cost for scanning. The gap is just so huge. And I know you must be thinking and you would say, okay, both of them executed very quickly, simply because the data is relatively very small. The moment you take these examples and deal with a large table, you would start seeing a huge gap between seeking and scanning. And this is where you got to make sure that your queries are sargable, they are depicting sargable behavior, and you got to get rid of all these examples, you know, where you are seeing non-sargability. All right, so questions in the Q&A panel, and hopefully you have understood this concept, and you should take a look at your workloads. First thing, is the index being used? Second, is it being used the right way? And there are a lot of DMVs out there which will give you this information that you know, you have the index, and is it being utilized for seeking or scanning? That could be a starter. You know, you could start that way. Yeah, this gives me an idea that I should actually record a demo, something around that. You know, when you have so many indexes, you want to find out all the indexes where SQL Server is scanning instead of seeking. That'll be a nice query basically. Okay. Some more examples there, but you can always, I mean, another example of non-sargability, which was similar to the earlier one where I'm using the left function, again, something before on the left-hand side of the equality operator, doing some mathematics, which will make this query lose its sargability. Let's do some cleanup and drop the index that we created. Hopefully you have understood the concept, you like the demo, and questions, please, in the Q&A panel. And now, let's close this file and move over to the next example, next demo.